Hey there, nice to see everyone. Let's talk today about quadratic functions and the graph of quadratic functions, okay? I'll give you some useful hints which you may use during your studies, and it really kind of makes easy the whole process of solving problems. Okay, first of all, let's talk about what quadratic function is. Quadratic function is a function which has x in the second power, okay? So the highest degree of the polynomial is the square. So let's put it this way. The standard form of a polynomial is like this: ax squared plus bx plus c. It's a standard form, okay? Standard form of a polynomial, or standard form of quadratic function. Standard form. Then, it's good to know that we also do have a so-called vertex form, which is y equals a times x minus h squared plus k. So this is a vertex form. Vertex form basically shows the coordinates of the vertex. H and k are exactly the coordinate of the vertex. Oops. H and k. If I put it this way here, so this is the vertex coordinates. Then, actually one more thing. A here and A here is the same A if we talk about the same equation, okay? Next, we have also the intercepts form, which are basically x-intercepts. And again, we have the same A, then x minus x2 times, x minus x1, kind of more logically, x minus x1 times x minus x2. Intercepts form, where x1 and x2 are basically the x-intercepts. Intercepts form. Well, as soon as you get this idea, you might be interested in what's the connection, basically. How to kind of turn from one equation to another one. Again, A is everywhere the same, okay? A is everywhere the same. Let me maybe put it this way as kind of sample problem to be clear what we are talking about. So let's say, let me put it here, y equals x squared okay, minus 3x plus 4, okay? Minus 3x plus 4. So here we have a equals 1, yeah, basically. Let me put it here. A equals 1, b equals negative 3. Please do not forget about the negative sign, okay? And c equals 4. It's good to know that if you want to find the vertex, basically the simplest way, okay? There are a few, but the simplest way is to, from this one, from the standard form, is to find the x-coordinate. So the h of the x-coordinate of the vertex, in other words, is negative b, coefficient over 2a. As soon as you find h, you could substitute it into the equation as x, and you get y. In other words, k here, okay? Let's substitute those numbers, negative 3, so it's positive 3, over 2a, 2 times 1 is 2. So it's 1.5 positive, okay? If I substitute this into the equation, I get k which is basically y coordinate for the vertex, k equals x squared, which is 1.5 squared, then minus 3 times 1.5, and plus 4. Well, 1.5 squared is 2.25. I really recommend you memorizing some of the squares, okay? Minus 4.5 and plus 4. So this becomes negative 0.5, right? And altogether, you get 1.75. 1.75. Super. With this, I could say, okay, I could rewrite this equation in the vertex form as follows. Y equals A, which is again 1, x minus h, which is 1.5, squared, plus 1.75. Let's check if this is really true. Let's go to the desmos.com site, okay? So what we had? X squared minus 3x plus 4. Y equals x squared minus 3x plus 4. Okay, looks like that's totally fine. Here's our vertex. 1.5, 1.75. Exactly. 1.5, 1.75. Okay, then this example illustrates that the intercepts form is not always kind of the case, because if we use the x-intercepts form, we need the intersections, okay, the intercepts of x-axis, but there would no be ones, since, as we see, this graph doesn't cross x-axis at all. So in any case, you could use the standard form. In any case, you could use the vertex form. But not in every case you could use the intercepts form, okay? It's not kind of as universal as the previous two. But if you do have the x-intercepts, let's change this a bit. Let me just show you. If I put here minus instead of plus, what would I get? Ta-dance. See? Now I got intercepts as -1 and +4, which is quite logical, since by Vieta theorem, yeah, we should say that if we have, maybe let me put it this way. Let me put it this way. Boom. Y equals x squared minus 3x minus 4. Let's recall the Vieta theorem. x1 plus x2 is the second coefficient, which is b, with a negative sign. So negative 3 is +3. And then the product of the roots would be the last coefficient, okay, or the free coefficient, -4. Which two numbers, being summarized, makes 3, and being multiplied makes -4. Make -4. 4 and -1. 4 plus -1 is +3. 4 times -1 is -4. See? So this is another case, the second case. Maybe take it as an example to the whiteboard. So this is our second case. Let me put it this way. Pretty not so bad. Let's see. So here is the graph, yeah? Here is 4. Here is -1. Again, if you have this notation, x squared minus 3x minus 4, and you want to find the vertex, now you could also use Actually, before that, let's again say, so if we want to use the intercepts form, we should simply put it this way: y equals a is 1, so I put just nothing before the parentheses, x plus 1 minus 1 times x minus 4. That's it. That's the equation of parabola. And if I expand this equation, I'll exactly get this thing, okay? But from this thing again, I could get the h and the y. Maybe let me put it a bit again smaller here. Darker. So again, for this one, I could say that h equals negative b, negative 3, positive 3 over 2a, which is 2, which is 1.5. Then k is equal to h squared minus 3h minus 4, which is again 1.5 squared minus 3 times positive now 1.5 minus 4, and eventually you get 2.25 minus 4.5 minus 4. And now it's better to combine these two, because 2.25 is exactly the half of the 4.5. So it becomes negative 2.25. And eventually get negative 6.25, which is precisely this value. Negative 6.25 and 1.5 is somewhere there, okay? If I am correct. If we take a look at here, sure, 1 and 2, exactly in the middle of those two, we have a vertex here, see, and 6.25 negative is here. So everything works perfectly. Then, from the intercepts form, you could get into the vertex form, or you could get into the so to the standard is easy, you just expand the parentheses. But to the vertex form, you could say, okay, if you have x1 and x2 here, which is negative 1 and positive 4, then h would be even simpler found just as the average of these two, negative 1 plus 4 over 2, which is 3 over 2, which is 1.5. See, so this kind of form, if it's kind of, if it exists, okay, if there are x-intercepts, could be utilized to find h very easily. So these are some simple hints. How could you get from one equation to another, and how you could see quadratic really behaves on the graph. And one more thing, if we have a vertex form and we want to find the standard form, let's say, okay, again, simply it's about the expanding the parentheses. If I put it like, let's say, y equals x, let's say minus 3, for example, so 3 is the vertex, squared, minus 1, and if we expand the parentheses, we'll get y equals x squared minus 6x plus 9 and minus 1 plus 8. So that's another form, that's a standard form of this equation. One more thing which I want to mention is if you substitute 0 into the standard form here instead of x, yeah, you right away get c. So basically, in the standard form, c is the y-intercept. So we had this negative 4 here, see? It's exactly here, it's negative 4. So y-intercept is always the free coefficient here if you substitute 0 as x. But then, same thing, if you kind of make x minus h squared 0, in other words, x would be equal to h in the vertex form, then y would equal to k. But this would be not y-intercept. This would be y-coordinate of the vertex. So these are kind of general things about quadratic function and its graph. We'll talk about it more. We'll go into details and discuss kind of several problems on that one. If you have some specific problems and you want to go over them, please leave comments, leave the information in the comments. I'll be happy to answer. Basically, that's it for now. I wish you all kinds of success in your study. Okay, see you and bye.